Hello everyone. In this video, let us study about electrocardiogram. This is Dr. Inbamalar working as professor in the Department of Electronics and Communication Engineering, R.M.K. College of Engineering and Technology. Electrocardiogram, called as ECG or EKG, records the electrical signals associated with the heart. ECG is a test that detects and records the strength and timing of the electrical activity of the heart. This information is recorded on a graph that shows each phase of the electrical signal as it travels through the heart. It is a common and painless test used to quickly detect heart problems and monitor the heart's health. So the electrocardiogram or ECG is basically a PQRST waveform. Here, if we consider the amplitudes, the three amplitude peaks present are called as P wave, R wave and T wave. In the ECG waveform, the amplitude and time period are significant. So, PR interval ST segment also plays a significant role. Actually, this ECG is giving the heart electrical signals. So, let us see the basic fundamental functions of a heart. The heart is composed of a contractile muscle similar to our skeletal muscle. The heart acts as a pump for our body's blood supply. Blood is pumped to the lungs to pick up oxygen via the right ventricle. Blood is pumped to the tissue to distribute oxygen throughout the body via the left ventricle. The heart consists of a upper layer called atria and a lower layer called ventricle. The upper atria is divided into right atrium and left atrium, and the lower ventricle is divided into right ventricle and left ventricle. So totally the heart consists of 4 chambers. Pulmonary arteries carry the oxygenated blood to the heart from the lungs, and aorta is a main artery that carries blood away from the heart to rest of the body. So if we consider pulmonary circulation, the impure blood from all the parts of the body are delivered to the lungs through right atrium and right ventricle for oxygenation, and the oxygenated pure blood from the lungs is delivered to all parts of the body through left atrium and left ventricle. Now, with the fundamentals of heart, let us see in detail about the electrocardiogram. The electrical signals originating in the SA node is responsible for the functioning of heart. These electrical signals begin in the sinoatrial node, which is located in the right atrium and travels to the right and left atria, causing them to contract and pump blood into the ventricles. This electrical signal is recorded as the P wave on the ECG. The PR interval is the time in seconds from the beginning of the P wave to the beginning of the QRS complex. The electrical signal passes from the atria to the ventricles through the atrioventricular node. The signal slows down as it passes through this node, allowing the ventricles to fill with blood. This slowing signal appears as a flat line on the ECG between the end of the P wave and the beginning of the Q wave. The PR segment represents the electrical conduction through the atria and the delay of the electrical impulse in the atrioventricular node. After the signal leaves the AV node, it travels along a pathway called the bundle of His and into the right and left bundle branches. The signal travels across the heart's ventricles, causing them to contract, pumping blood to the lungs and the body. This signal is recorded as the QRS waves on the ECG. Because these waves occur in rapid succession, they are usually considered together as the QRS complex. The ventricles then recover to their normal electrical state, shown as the T wave. The muscles relax and stop contracting, allowing the atria to fill with blood, and the entire process repeats with each heartbeat. The ST segment connects the QRS complex and the T wave and represents the beginning of the electrical recovery of the ventricles. The QT interval represents the time during which the ventricles are stimulated and recover after the stimulation. This interval shortens at a faster heart rate and lengthens at a slower heart rate. So this electrocardiogram shows you the PRT peaks, QRS complex, and here you can see the P wave is due to atrial depolarization, QRS complex is due to ventricular depolarization, and the T wave is due to ventricular repolarization. So now let us see the depolarization and the repolarization with respect to heart. When electrical activity occurs, heart muscle fibers are contracted and produces a movement. This condition is referred to as depolarization. When blood is pumped around the body, it results in contraction. When chambers are contracted, it is called systolic. The relaxation of heart muscles are called as electrical repolarization. Relaxed heart chambers are called diastolic. Now let us see the amplitude and time duration of the PQRST waveform. As we all know, P wave is due to the depolarization of the atria. Its amplitude is 0.25 millivolt and time duration is 0.12 to 0.22 seconds. The R wave, otherwise QRS complex, is due to the repolarization of atria and ventricle contraction, have amplitude of 1.6 millivolt and time duration 0.07 to 0.1 seconds. T wave is due to relaxation of myocardium with an amplitude 0.1 to 0.5 millivolt and time duration 0.05 to 0.15 seconds. U wave is due to slow expansion of Purkinje fibers with amplitude less than 0.1 millivolt and time duration 0.2 seconds. Now let us see how this electrocardiogram helps a health provider to diagnose heart diseases. First, let us see about heart rate. Usually, heart rate can be measured by checking the pulse. An ECG may be helpful if your pulse is difficult to feel or too fast or too irregular to count accurately. An ECG can help identify an unusually fast heart rate termed as tachycardia or an unusually slow heart rate termed as bradycardia. Next, heart rhythm. ECG can detect irregular heartbeats, which is termed as arrhythmia. An arrhythmia may occur when any part of the heart's electrical system doesn't work properly. ECG can help us to identify heart attack. An ECG can show evidence of a previous heart attack or one that's currently happening. The patterns on the ECG may help determine which part of the heart has been damaged as well as the extent of the damage. ECG helps to blood and oxygen supply to the heart. An ECG done while the patient is having symptoms can help the healthcare provider determine whether reduced blood flow to the heart muscle is causing the chest pain. ECG can be used to detect heart structure changes, and ECG can provide clues about an enlarged heart, heart defects and other heart problems. Thank you for watching my video.